Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 050. The purpose of this video is to explain the concept of slope and rate of change. So as you can see here, I've got a couple of graphs of two different linear functions. The one on the left has negative slope, and slope tells us essentially how steep this line is and the direction in which that line is moving. So negative slope implies that a line is going to be moving downward from left to right, as this picture depicts here. And of course, the steeper this line is, the more slope it has, and the less steep the line is, the less slope it has. You can kind of think about it as like the pitch of a roof. If the pitch of a roof is really steep, right, that would have a lot of slope on it, or like a ski slope, for instance. Like a double black diamond ski slope is going to be really steep. It's going to have more slope. And then positive slope is a line that moves upward as we go left to right, and this would be an example of positive slope. And once again, the steeper that line, the greater the slope's going to be. Okay, so that's how we can have an idea of what slope is graphically. We can also actually calculate slope from a graph if we have 2 points that are on the line. So notice I have 2 points here on our positive slope. Let's take a look at it first. Okay, let me focus in on that. Okay, so the two components that compose slope is rise and run. The rise tells us the vertical change between those 2 points. And so that's depicted by essentially moving from the lower point up to the upper point, and we can see that is a difference of 2 units. The y-coordinate for this point is 1, and the y-coordinate for this point is 3. Therefore, the rise equals 2. And the run tells us the horizontal change between those 2 points. So if we look at the lower point here, its x-coordinate is 2. This point here has an x-coordinate of 4. Therefore, there's a difference of 2 units between those 2 points horizontally. So if I have rise and I have run, then I have slope. And slope is depicted by the letter M, and it is the rate of change between the rise and the run, which is rise over run. So if the rise is 2 and the run is 2, 2 divided by 2 is 1, and of course our slope is moving upward from left to right, so we say it has positive slope, so then we would say the slope is positive 1. Right? So essentially, if I look at my graph, if I go over 1 and up 1, that puts me at another point on the line. Over 1, up 1, so on and so forth. Okay. So as I go up 1, as I rise 1, I run 1, and that gives me another point on the line. So the slope describes essentially the rate of change of that line, right? How the line is moving or changing as we move from one point to the next. Okay. Negative slope. We can also use a graph of it to calculate its slope, and of course we look at the line and we can tell that it's going to have a negative slope, and we could still once again calculate the rise and the run. So the rise is the change in the vertical position between those 2 points. So the y-coordinate of this point is 4. The y-coordinate of this point is 1. So that means there's a change of 3 units. So 1, 2, 3. So 3 units. So the rise equals 3. Okay, and then the run is the horizontal change between those 2 points. So there is a change of 1 unit between those 2 points. The x-coordinate of this point is negative 4. The x-coordinate of this point is negative 3. So that's a difference of 1 unit. So the run equals 1. Okay. So then once again we can find the slope by doing the rise over the run. So 3 over 1, which equals 3, and of course this is negative slope, so we say negative 3. So the sign of the slope actually tells us in which the direction the line is moving. The number tells us essentially how the points are changing from one point to the next, right? So if I'm at this point, if I rise 3 and go left 1, I am on another point on the line, right? Okay, so that's how we can find slope graphically, which describes the rate of change. I can also find slope mathematically if I'm given 2 ordered pairs that are on a line. So here is our slope formula to find slope between 2 ordered pairs. Once again, the letter M represents slope. Notice that I am subtracting the y-coordinates to find the slope. That is the rise, so the vertical change, over subtracting the x-coordinates, the run, the change in the horizontal position between those 2 points. And the ratio of those 2 changes of the vertical position and the horizontal position tell us the rate of change, or slope. So here's 2 points that is on the line. So what I recommend students do is to label the 2 points. Label the x-coordinate of the first point x1, the y-coordinate of the first point y1, and then label the x-coordinate of the second point x2 and the y-coordinate of the second point y2. And when you do that, it essentially gives you the numbers to put in this slope formula. So in this case, y2 is negative 2 minus y1, which is 5, over x2, which is 6, minus y1, which is negative 1. Simplify the top. Be very careful of your sign. So negative 2 minus 5 is negative 7. And 6 minus negative 1, those double negatives are going to turn to positives. So that's going to give me positive 7. So negative 7 divided by 7 is going to be negative 1. So the slope would be negative 1. Right? So that would tell me that this line is moving downward as we move left to right. And if I go down 1 and right 1, that would give me, or put me on the next point on that line. Okay, so that's one way we can interpret slope, how to find slope between 2 points. And you're basically just finding rise over run. Like I said, you're just doing it analytically with the numbers instead of graphically. All right. So once we have an idea of what slope is and what slope tells us, then we can actually use slope to try to write an equation of a line. And one form in which we can write an equation of a line is slope-intercept form. Hence the name slope-intercept form. It gives us the slope, which is m, and the y-intercept, which is b. So this is the format for slope-intercept form, y equals mx plus b. If I can rewrite a linear equation and put it in this form, then I automatically will know the slope and the y-intercept, which will then help us to graph equations later on down the road. So here's an equation, 3x minus 5y equals 1. So we essentially want to solve this for y. So the first thing that we want to do is move the x term over, and the 3x's are going to cancel. And of course 1 and minus 3x are not like terms, so I can't combine those. So I keep them separately, and I want to write the x term first, just so I can follow suit with this y equals mx plus b. And then the last thing would be to divide by -5. So that gives me y equals, and then of course -5 is not going to divide in the -3, so that's going to remain a fraction, and a negative divided by a negative would actually be a positive, so we're going to call that positive 3/5 x. And then -5 is not going to divide into 1, so we're going to once again leave that as a fraction, and we're going to say that is -1/5. That way we don't have to write plus minus. Subtraction is the same thing. So now it's actually in slope-intercept form. The coefficient of the x term is the slope, so the slope is going to be 3/5. And then the constant, that is the second term, is the y-intercept. That's what we call b. So that's where our graph is going to cross the y-axis, which is -1/5. And we're actually going to use this quite a bit, especially in future sections. We can actually use this to graph linear equations. So another way to graph. So I would recommend getting good at this, and we're also going to use this in other sections as well once we start talking about parallel and perpendicular lines. And this is really good knowledge when you go forward in other math classes as well. Okay, so that's slope-intercept form. Okay, and then the next topic in this section is parallel and perpendicular lines. So let's start with parallel lines. Parallel lines are lines that do not intersect. So one of the key characteristics of parallel lines is that the slopes of those lines are equivalent. I think I just need one R here. Okay. So if two lines have the exact same slope, then they would be parallel lines. So an example of parallel lines would be something like this. Okay. So here's a line, right? It had slope of rise 2, run 1, so it has slope of positive 2. So if I draw another line that also has slope of positive 2, they would be what we would consider parallel lines. And not only do parallel lines have the same slope, they also, because of that, will never intersect. So you can think of, like railroad tracks, or like the two yellow lines in the middle of a road if it's a two-way road. Those lines will never intersect. So those are key characteristics of parallel lines. Okay, so parallel lines have the same slope, they never intersect. So let's take a look at an example of two linear equations. Negative x plus 2y equals negative 2. 2x equals 4y plus 3. So these two lines are not in slope-intercept form. If they were both in slope-intercept form, then I could determine what the slope would be, and then determine if these two lines are parallel or not. So let's actually take a look at the first equation. So we're going to label it equation 1. So in equation 1, I want to solve this equation for y just like we did earlier and put it into slope-intercept form. So to do that, I'm going to add x, and of course x and negative 2 are not like terms, they're not going to combine. I'm going to write the x first, okay, and that's a 1x. Then I'm going to divide by 2 to get y completely isolated, and be sure that to divide everything by 2. Right, that way the equation stays balanced. So y equals positive 1/2 x, because 2 is not going to divide into 1, so that's going to stay a fraction, and then 2 divided by 2 is obviously 1. So now this is in slope-intercept form. Okay, the slope of this equation is 1/2. That's the coefficient of the x. The y-intercept of this equation is negative 1. Okay. So that's equation 1. Let's put equation 2 in slope-intercept form. And then we can determine what the slope is and go from there and see if these two lines are parallel. Okay, so I'm going to solve this for y. So I'm going to minus 3 from both sides. So that's 2x minus 3 equals 4y. And then I'm just going to reverse this, just to put y on the left side and x on the right side. Divide everything by 4. So y equals 2 divided by 4, that's a fraction, 1/2, minus 3/4. So once again, the slope is 1/2. The y-intercept is negative 3/4. So if we compare these two, they both have the same slope, and they have different y-intercepts. So because of that, these two lines would be parallel lines. So that meets the criteria, right? Both have the same slope, they have different y-intercepts, so that would tell us that these two lines would be parallel. So by putting that equation, or those two equations, into slope-intercept form, we can easily determine whether lines are parallel because we're able to identify their slopes. Alright. Another type of line that I wanted to talk about is perpendicular lines. So perpendicular lines are lines that are going to intersect to form a right angle. So an example of two perpendicular lines would be something like this. Right, those two lines intersect to form a right angle. So you can kind of think of like a four-way intersection on a road, right? You know, two lines intersect to form a perpendicular or right angle. Okay, so one of the defining characteristics of perpendicular lines is that their slopes are negative reciprocals, or I'm sorry, not negative, opposite reciprocals of each other. So let's just take a moment to get an idea of what an opposite reciprocal is. Well, okay, so opposite means to have the opposite sign, and reciprocal means to essentially flip the fraction. So let's say, for example, I had a slope of -1/2. The opposite reciprocal would have the opposite sign, so instead of negative it would be positive, and then the reciprocal would just be this fraction flipped. So instead of 1/2 it would be 2/1, which would obviously equal +2. So -1/2 and +2 are opposite reciprocals of each other. If I had one line with a slope of -1/2 and then another line with a slope of +2, I would know that those two lines would be perpendicular. They would intersect to form a right angle. Okay, let's just look at another example. Let's say I had a slope of 3. Right? What would be the opposite reciprocal? Well, obviously it would have an opposite sign, so instead of positive it would be negative. And then of course I can write 3 as 3/1, so if I flip that I would get -1/3. So +3 and -1/3 are opposite reciprocals of each other. If one line had a slope of 3 and the other line had a slope of -1/3, they would be what we call perpendicular. Okay. So I got another similar example here. I've got two equations. Label the first one and the second one, and we want to once again put these into slope-intercept form to determine whether they're parallel or perpendicular or neither. If the slopes were neither the same or neither opposite reciprocals of each other, then they wouldn't be neither. They would not be either parallel or perpendicular, and we would say they were neither. So let's put the first one into slope-intercept form. So solving it for y. So that one's kind of easy. I just need to essentially, first of all, let's flip it around so that y is on the left side, and write x as the first term. So we can divide everything by 3. And that's going to put this into slope-intercept form. So the slope is 4/3. That's what we want to identify here. Okay. Let's solve the second equation for y, putting it in slope-intercept form. So -3x to both sides. So 4y equals -3x plus 8. Divide both sides by 4. Y equals -3/4 x plus 2. So the slope here is -3/4. So we want to compare those two, right? They're obviously not parallel because they're not the same slope. So are they opposite reciprocals? Well, they have opposite signs. One's positive, one's negative, and they are reciprocals. If I flip this fraction and put the denominator as the numerator and the numerator as the denominator, I get 3 over 4. So they would be opposite reciprocals of each other. So we would say that these two particular lines would be perpendicular. And we can determine that by, once again, putting those two lines in slope-intercept form, and then identifying the slope and noticing that the slope is opposite reciprocals of each other. Okay. Alright, and then last but not least, wanted to share two special types of lines. We talked about these lines in the previous section. Horizontal and vertical lines. So remember, if you have x equals just a constant, that's going to be a vertical line. Basically, every point on that line is going to have an x coordinate, in this case of -2. So I'm just going to do a rough sketch here of the graph. Here's -2. So that line would look like this. It would be vertical going through -2 on the x-axis. Right. So what type of slope does that line have? Well, if we think about slope as being steepness, that's as steep as you can get, straight up and down. Right. So because of that, we say this slope is undefined. Right. So essentially that's as steep as it can get. Right, so it's so steep that I can't measure it. That's one way to think about it. Right, if this line moves either way in any direction, right, I could then measure that slope, because then it would be less steep. Okay, so vertical lines have slope that is undefined. So what about horizontal lines? So if we have an equation like y equals 3, where y equals just a number, that's what we call a horizontal line. So if we graph that, remember that is going to be the horizontal line where all the y coordinates equal +3. So that's actually going to look something like this. It's going to be a horizontal line crossing the y-axis at 3. So what's the slope of that line? Right? Well, that's completely flat. Right? So think about the horizon, horizontal line, right? We say that has a slope of 0. Right? It is not steep at all. It is exactly 0. No steepness to it at all. So slope of 0. It's completely flat. Okay. So those are two kind of special lines that you would want to keep in mind to identify slope of a vertical and a horizontal line. So hopefully this video helps you to find slope of a graph, of a line, slope between two ordered pairs using the slope formula, how to rewrite a linear equation in a slope-intercept form to identify slope and y-intercept, and then how to identify lines as being parallel or perpendicular. All right. If you have any questions, as always, email those questions to me or stop by the office. Have a great day.